Dear the President of Ubon Ratchathani University, International Conference on Mechanical Engineering is an annual conference which is held by the Thai Society of Mechanical Engineers, or TSME. The conference is aimed to bring together leading scientists, researchers, and research scholars to exchange and share their experience and research results in the field of mechanical engineering. The conference has been carrying out for more than 10 years continually. This year's conference is the 11th time and hosted by Department of Mechanical Engineering, Ubon Ratchathani University. The theme of this year's conference is Challenging Trends in the Mechanical Engineering, and is held for 4 days during December the 1st to the 4th, 2020 at Sunee Grand Hotel and Convention Center, Ubon Ratchathani, Thailand. This year, there are about 132 papers submitted for presentation, and there are about 180 delegates from many countries. Join the conference including online and in person. On behalf of organizers of the conference, we wish to thank partners who have been supporting this conference, which are the Research and Service on Energy Center, or RSEC, Total Engineering Thailand Company Limited, Kinetics Company Limited, FT Energy Company Limited, the Japanese Society of Mechanical Engineers, or JSME, and the Korean Society of Mechanical Engineers, or KSME. On behalf of the organizer team, it is our honor to have the President as a chair of the opening session. It is about the time now. So, may I invite the President to deliver opening speech and welcome the delegates, please.
Dear President of the Thai Society of Mechanical Engineers, Professor Dr. Wirachai Roynarin, speakers Mr. Yukio Yoshida, and Assistant Professor Dr. Wirachai Roynarin, and the Dean of Faculty of Engineering, Assistant Professor Dr. Mongkul Pusiapanan, and well delegates. First of all, please may I warmly welcome you to the 11th International Conference on Mechanical Engineering, or Icome 2020. It is my great pleasure to be here for the opening session. As far as I knew, this conference is one of the greatest international conferences in engineering. And on behalf of Ubon Ratchathani University, it is our greatest honor to be a host. Mechanical engineering is one of the important fields necessary to lead this world to better future. As we knew well that the world these days, especially Thailand, are facing a lot of challenges such as shortage of energy and global warming, rising of aging society, shortage of human power and demanding of robot and AI technologies, safer and more efficient transportation in COVID-19 crisis. These challenges need know-how, technique, technology, and innovations from mechanical engineers. And I believe this conference will play a main role to deliver solutions for those. On behalf of UBU, which our vision is to be a leading university in ASEAN, focusing on transforming life quality and innovations. Together with our staffs in Mechanical Engineering Department, we are ready to work side by side with mechanical engineers around Thailand and around the world to accomplish our mission to lift up life quality of people. Lastly, I wish to thank all staffs of the Department of Mechanical Engineering UBU to host this conference. I also wish to pay my gratefulness to the Thai Society of Mechanical Engineers for providing a chance for UBU to serve as a host. I hope all delegates will enjoy and have it while attending every session of this conference. I also hope this conference will be fruitfully, perfectly, and smoothly completed. Thank you.
Thank you very much, President of the Rajamangala University and also Head of Department of Mechanical Engineering. May I ask the President to stay on the stage for the certificate presentation. Thank you. And next, as I said before, this conference will not be possible without supporting and sponsorship. So next, there will be a certificate of sponsorship presentation from the university as the host. Okay. May I call upon the four sponsors who have been supporting this conference and made it possible. First of all, may I ask the representative from Research and Service on Energy Center on the stage to receive the certificate of sponsorship, please. Representative from Research and Service on Energy Center, please. Thank you. And next, the representative from Total Engineering Thailand Company Limited.
And next, the representative from Kinetics Corporation Limited. And the last one, representative from FT Energy Limited.
These are the sponsors for this year's conference. Thank you very much once again on behalf of the university. Thank you very much, President. And next, the next session is the presentation of Memorial Award. Okay. And on this occasion, thank you very much, President. And on this occasion, may I invite President of Thai Society of Mechanical Engineers on the stage to present the Memorial Award. Please. Thank you very much. And for this year, the person who will be receiving this Memorial Award is Professor Dr. Somchai Wongwisit. May I tell you briefly a little bit about Professor Dr. Somchai Wongwisit? Professor Dr. Somchai Wongwisit works at the King Mongkut University of Technology, Thanyaburi, in the Faculty of Engineering. He is also the Royal Master in Engineering in the Royal Society of Thailand. He received his PhD in Mechanical Engineering from University of Hanover, Germany. He also received his doctorate degree from Chulalongkorn University. And he has done a lot of work. For example, in 2003, he was the senior researcher scholar.
ท่านแรกที่จะขึ้นพูดคนแรกนี่คือคนไหนอะครับ
supported by the Thailand Research Fund. And also he was the best teacher or lecturer in King Mongkut University of Technology, Thanyaburi in 2009. And also best professor in 2010. Outstanding government official of the University of King Mongkut University of Technology, Thanyaburi in 2018. And also, he received a highly cited researcher, world top 1% in engineering of climate analytics in 2017, 2018, 2019, and 2020. Ladies and gentlemen, please give a big round of applause to Professor Dr. Somchai Roynarin. Now, may I ask the President of Thai Society of Mechanical Engineers to present the awards to Professor Dr. Somchai Roynarin. Thank you very much, Mr. President. On this occasion, I think Professor Dr. Somchai may want to say a few words about what he feels for receiving this award.
ไม่ได้เตรียมมาพูดเลยภาษาอังกฤษ
เขาก็บอกให้ผมเชิญท่านอาจารย์
I would like to express my sincere appreciation and thanks to JSB for awarding me with this plaque as that's called senior mechanical engineering professor. So I am truly honored with this recognition. Receiving this honor is like a huge encouragement, which will make me keep moving forward purposefully for teaching, research, mentoring, or serving people, as I have done. Yes, purpose of my life. Okay, I would like to say again that I am deeply, truly honored for this event. Thank you very much.
Seems like it's a big problem for Ajahn because your Ajahn is the best lecturer.
May I ask both Professor Somchai and Professor and the President to stay on stage once again, please, for a group photo. And on this occasion, may I also invite the President of Ubon Ratchathani University, the Dean of Engineering, the Head of Department of Mechanical Engineers, our keynote speakers, Mr. Yukio Yoshida, and Asst.Prof.Dr. Wirachai Roynarin, and also the Vice President of the Thai Society of Mechanical Engineers, Associate Professor Dr. Gulachet Pientong, on the stage, please, for a group photo. And this is the first set of the group photo. We'll take another photo later on.
พอดีครับ
may I also invite this time the committee of the Thai Society of Mechanical Engineers and the head of departments of mechanical engineering from several universities, on the stage for another group photo, please. Do you have enough space on the stage?
โทษนะครับ
ช่างภาพแจ้งได้นะครับอย่าได้บอกนี้ Thank you very much, everyone. Thank you. And may I ask the President of Thailand University, President of Thai Society of Mechanical Engineers, to stay on stage once again, please. เรียนเชิญท่านในการและท่านนายกสมาคมอยู่บนเวทีสักครู่นะครับครับผมท่านนายกสมาคมเรียนเชิญอยู่บนเวทีสักครู่นะครับขอบคุณครับ And lastly, because this year Thailand University is hosting this conference, so the Thai Society of Mechanical Engineers will present a token of appreciation to the university, and also the university will also present the token of appreciation to the society, please, by both the presidents. Thank you very much, the President of Rajamangala University and also the President of Thai Society of Mechanical Engineers. Thank you. Okay, we've done all the ceremony.
Okay, and
I
it's
think
time
yes.
for the very important time as well. Here we're gonna listen our keynote speakers
Okay.
who have lots of experience.
Yes.
And
We have two keynote speakers.
yeah,
The first one will be talking about the trends of future technology transforming the automotive industry. And our first keynote speaker is Mr. Yukio Yoshida, Vice President of Technical External Affairs Division, Toyota Daihatsu Engineering and Manufacturing. And the second keynote speaker is
Asst.Prof.Dr.Wirachai Roynarin, the Head of Research and Service Energy from Center Rajamangala University of Technology, Thanyaburi. And I would like to introduce you about the short biography and work experience of our first keynote speaker, Mr. Yukio Yoshida. Mr. Yukio Yoshida started to work as an engineer in Engine Development Division, Technical Center, Toyota Motor in the year 1983 to the year 2004. And then he was promoted to be Vice President of Toyota Motor Asia Pacific Engineering and Manufacturing Thailand, and Powertrain Engineering Division, Technical Research Division, and Vehicle Evaluation Division. in the year 2005 to the year 2009. And during the year 2010 to the year 2012, he was responsible for working as a group manager, strategy management department, product development, and management division at Toyota Motor Corporation Japan, powertrain strategy making. And in the year 2013 to the year 2016, he was a project general manager, powertrain planning department, powertrain unit management division, Toyota Motor Corporation Japan, strategy making and product planning of powertrain. And in the year 2017 up until now, he is Vice President of Technical External Affairs Division, Toyota Daihatsu Engineering and Manufacturing Co. Limited.
I think our speaker is now ready. So, ladies and gentlemen, please welcome our first keynote speaker, Mr. Yukio Yoshida.
This mic is okay. Test. Sorry ครับผู้มีเกียรติทุกท่านผมชื่อยูคิโอโยชิดะที่บริษัท Toyota Daihatsu Engineering and Manufacturing. This is all my Thai language. I have started English. Congratulations, Icome and Tsme and Bon Ratchathani University. You success to have this Icome 2020 in this year, in spite of challenging situation. Congratulations. It's my great honor to have a presentation at this Icome 2020. Okay. Hi. Recently, there is a big movement, like once in the century, Toyota also tried to shift from the automotive maker to be a mobility company. Today, I'd like to present about trend of future technology and transformation of the automotive industry. My presentation will cover three main topics, starting from environmental issue which we are facing today, followed by automotive industry challenge, and lastly about sustainable society. This mic okay? As we all know, the climate change and pollution are global serious issues. And we are now feeling the effects everywhere, like global warming, air pollution, and etc. This will be our challenge to take action to overcome environmental issues. In 2015, at COP21, first global commitment meeting was adopted in Paris to fight the climate crisis. And the global is the goal is to limit the rise in global advantage temperature below plus 2 degrees. Newly, 200 countries had set on targets to reduce CO2 emission, which is called Paris Agreement. For example, US 26 to 28 by 2025, and EU and 40%, China 60 to 65% by 2030. And Thailand also committed achieve to 20 to 25 reduction by 2030. Even though almost 97% countries worldwide had set their emission reduction target under the Paris Agreement, it became clear that this is still not enough to reach plus 2 degrees target. This is Paris Agreement line, and this is plus 2 degrees line. Still a large emission gap. Furthermore, the global goal is to achieve a safer limit for the world at below plus 1.5. This means huge reduction of CO2 is necessary to achieve our acceptable levels. Not only global warming, but many countries, including the ASEAN region, are also facing air pollution problems. Especially PM 2.5, which becomes a serious issue like Thailand and Vietnam and Indonesia. Thai government has already taken seriously actions to reduce this issue, response to this issue by encouraging B20 biofuel usage, considering enforcement Euro 5 and Euro 6 emission regulation, promoting electrified vehicle, and even the end-of-life vehicle policy. Indonesia and Vietnam still not rise into social issue yet, but in the near future they would take similar actions. Next, I would like to talk about the automotive industry challenge. Sorry. Toyota announced the environment challenge for 2050, and we have committed our efforts with 2 main pillars and 6 challenges. First pillar is the challenge of achieve zero CO2 emission in vehicles in life cycle and manufacturer. Another pillar is net positive impact challenge. Minimize and optimize water usage and establish recycle-based society and establishment of future society harmony with nature. Toyota would like our planet cleaner through these activities. Today, I would like to talk mainly about new vehicle CO2 emission challenge. Toyota has set target to reduce CO2 emission of new cars in 2050 comparing to 2020. 2010. How to achieve this target? Vehicle electrification is essential, include various technology and energy. Toyota has approached all-encompassing electrification technology such as hybrid electric vehicle and plug-in electric vehicle, battery electric vehicle, fuel cell electric vehicle. That's because we believe responding to the diversified energy sources such as biofuels, electricity, and hydrogen. This will lead to proper energy mix. On the other word, the energy source should truly match the energy situation in the country, each country. So we need to consider all-encompassing approach to all electrified vehicles and energy diversity. Furthermore, normally, when we're talking about the CO2 emission, we are usually talking only tailpipe emission. However, we should look into total CO2 emission from the very beginning of energy production until tailpipe emission. That is called well-to-foil. This thinking way is very important for the future CO2 reduction. In Thailand, where the variety of agricultural crops, including sugarcane and cassava and palm, apparently there is a potential for alternative fuel like ethanol and biodiesel. Moreover, CO2 is absorbed during plantation and could be realized at carbon neutral. On the other words, CO2 emit equal to absorption. So Thailand should consider the realization of the low CO2 society by using fuel efficient vehicle like hybrid with ethanol fuel. According to well-to-foil CO2 analysis of Thailand, the combination of E85 fuel and hybrid technology will be most effectively reduce CO2 up to 60% from conventional gasoline vehicles. Looking into uniqueness of energy sources like Norway, it's possible to reduce clean electricity from possible to produce clean electricity from abundant hydropower. So it is considered the realizing of low CO2 society by using battery EV in the viewpoint of a well-to-oil. For the countries with less energy resources, like Japan, they are challenging to use hydrogen energy and realize hydrogen society from the viewpoint of energy security. In case of the zero-emission vehicle, like battery EV and FCEV, even though tank-to-oil is zero emission, but depend on the energy source. Current Thailand electricity is mainly from natural gas and coal, so that's emitted, make electricity that emitted around this volume. So well-to-oil of battery EV still have high CO2 emission. Likewise, hydrogen must be produced from clean sources. How to reduce production CO2 emission is the point. Zero-emission vehicles require zero-emission energy. I will show you a video of hybrid system. これサウンド、音。サウンド見ない
engine and motor. Then this system combines these with the power split device to achieve high energy efficiency. This is the Toyota hybrid system. Each unit has been developed specially for the hybrid system. For the engine, the maximum thermal efficiency has been raised and both low fuel consumption and low emissions achieved. The motor is compact and high efficiency to achieve smooth acceleration. The generator uses the engine rotation to generate electricity, which is sent to the motor and the drive batteries. It is also used as the engine starter and provides smooth engine starting. The power split device contained in the transaxle is Toyota hybrid core technology that divides the energy output from the engine between electrical generation and driving according to the driving conditions. The power control unit is the core of the hybrid system. It controls the electricity to provide appropriate amount to each unit. The drive batteries store the generated electricity and supply it to the motor to drive the vehicle. There is no need to recharge from an outside power source or to replace the batteries periodically. They also provide superior durability and heat resistance. Toyota hybrid units have the reliability made possible by years and years of design development and continuous progress. For a Toyota hybrid vehicle, when not moving, all units stop and there is no wasted energy consumption. When the vehicle starts off, the motor drives it quietly and smoothly. For driving at low speed, the motor is used to achieve low fuel consumption. During the acceleration, motor drive is combined with engine drive in a rotation range with good engine efficiency to drive the vehicle powerfully, yet with low fuel consumption. The engine drives the vehicle and charges the batteries at the same time to raise the energy efficiency. During deceleration, the rotation of the tires drives the motor to generate electricity to store the power into the batteries for reuse. In this way, a Toyota hybrid vehicle runs the engine in a rotation range in which the engine has good efficiency and that matches the driving conditions and reuses energy that has been wasted until now and achieves low fuel consumption driving. The Toyota hybrid system is advanced technology that achieves both driving fun and superior environmental performance.
Another type of electrified vehicle is a plug-in hybrid electric vehicle, which is the integration and innovation of combination hybrid and battery EV technologies. In real world use, it provides a proportion of the daily driving that can be covered with EV, electrified vehicle mode, by battery power alone. And in case of the long distance needed, during holidays, there will be no concern for the battery running out, as the car can also run with hybrid mode. Regarding battery EV technology, the problem for automakers have always been the balance between the size of battery and driving distance of car without additional charge. Honestly, for behavior of car weight or long distance, vehicle weight and the vehicle distance, driving distance, require the high battery cost. That directly results in the high vehicle price in the market. This would be one of the biggest challenges for automotive industry to achieve low battery cost in the future. At the present time, battery EV is more suitable for small car and short distance. Therefore, from XEV, electrified vehicle categorization, we think that is necessary to expand and popularize hybrid and whereas plug-in hybrid to create a mass volume as a fundamental technology. And start battery EV from small size vehicle, and while FCEV from big size vehicle, such as a bus and a truck. Later on, expanding battery EV and FCEV for wider range of usage. Next, fuel cell technology. This video will show you how FC system works.
Which is created from hydrogen and oxygen. Hydrogen, an alternative fuel for gasoline, is a plentiful, environmentally friendly energy element that is created from a wide range of sources. Hydrogen and oxygen create electricity, which powers the motor. Without burning hydrogen, the only emission while driving is water, and no carbon dioxide is emitted. The motor provides exceptionally smooth acceleration, making the FCV fun to drive. This is how the electricity is generated. The car takes in oxygen from the air, which meets hydrogen from the high-pressure hydrogen tank in the fuel cell. Many fuel cells combine to form the fuel cell stack. Hydrogen is supplied to the negative anode and activates, releasing the electron. Then the electron flows to the positive cathode to generate the electricity. After releasing the electron, the hydrogen becomes a hydrogen ion, moving to the positive cathode and bonding with the oxygen in the air, forming water. Hydrogen and oxygen come together in the fuel cell stack to supply the electricity to the electric motor via the power control unit. FCV controls the electricity created by the fuel cell using technology developed from the hybrid vehicle. The motor works as a generator, gathering energy when the car speed is low. This accumulated energy is stored in the battery to support the fuel cell when accelerating. The FCV has the ability to start in extreme cold and can perform in almost any condition. FCV, the future of driving has arrived.
As you see from video, FC fundamental technology can be diversified into other applications, and Toyota will expand the product lineup from passenger car like a Mirai, this is a Mirai, to commercial vehicle like a bus and a truck. In addition to vehicles, we will also develop products for various industries products such as forklift, FC power generator, and a train, ship, and so on. We provide FC system. As electrified vehicle has potential for CO2 reduction, each type of electrified vehicle has its own unique main components as shown in the diagram to enable mobility. However, motor and battery and inverter are core components, common core components in the electrified vehicle. For example, core components plus engine is a engine make a hybrid vehicle. Core components plus charger, that make a battery, like that. Next, in addition to electrified vehicles technology, I would like to address about sustainable society as well. Toyota does not only consider simply to introduce electrified vehicles into the world, but also think about environment and resources limitation in order to have circular economy and sustainable business. Battery, as one of the core components of electrified vehicle, it contains rare metal such as nickel, lithium, and cobalt. So it should be, in addition, it also contains substance of concern. So it should be controlled not to be disposed easily. Without efforts such as reuse and recycling, it will lead to problems such as price increasing due to shortage of resources and increase of industry waste as demand for electrified vehicle increases. So, Toyota has been working to maximize battery life usage with the concept of 3R: rebuild, reuse, and then recycle. After recover used battery module will be classified its performance, and if still high efficiency, it will be used as a battery replacement for vehicle, which called rebuild, used by vehicles. And while moderate efficiency module will be used for energy storage system, which called reuse, and rest will be sent to recover precious material as recycled. Currently, our 3R activities has been implemented in Thailand since September of 2019. Furthermore, aiming for long-term sustainable society, it's important to create zero-emission energy. Electricity and hydrogen should be produced from renewable energy sources, together with considering efficiency energy management to cover the power demand in industry and transport application. Finally, new vehicle zero CO2 emission challenge. It cannot be success without cooperation among all stakeholders: government, customers, energy suppliers, and automakers. This concludes my presentation. Thank you very much. ขอบคุณมากครับ
Thank you very much, Mr. Yoshida, for sharing an interesting and successful information on this state-of-the-art training of future technology transforming the automotive industry. And next, I would like to invite the President of Thai Society of Mechanical Engineers to present a token of appreciation to Mr. Yoshida.
I will give you some
Thank you very much.
This way.
Thank you.
Thank you very much.
Thank
It
you
is a
very
great honor for GSME.
Thank you very much.
Give an applause to our presenter, Mr. Yoshida.
As you can see that the presentation is very interesting.
Thank you very much.
So I'm wondering whether there is any questions from the floor at all. If you have any questions, please let me know. Are there any questions from the floor, please?
My name is from Rajamangala. Yes, your presentation is very interesting. Indeed, I have so many questions to you. First of all, it seems that your idea in Thailand now, how to say, the Toyota is So one organization in one company that have a different idea. As you might know, in Thailand, now so many people are, how to say, crazy about the BEV, electric vehicle. Many organizations talking about the BEV. They believe in Elon Musk. They believe in the direction of China. Because if you see that, Elon Musk said that in the future, in the near future, the world is going to change to electric vehicle. And China invests a lot for the electric vehicle. Yes. And also in Thailand, many people also believe in the, how to say, in the near future. We should switch from the combustion engine to electric vehicle. But here from your presentation, you have a different idea. And also if I look at in Japan, there's some company like Nissan, they invest a lot and then sell a lot, sell some electric vehicle, but Toyota is not. So I just want to ask you an idea. How to say, in Thailand, Toyota, I think you hold the biggest market share for the passenger car in Thailand. But now in Thailand, Thai government, they consider about to use more electric vehicle. They plan to buy a lot of the electric bus from China, or even many in Thailand. And then look in China, in some big country, in some big city, they also convert 100% of the bike motorcycle to be electric motorcycle. So I just want to ask you, the Toyota idea, don't you worry that maybe if you, if you still, consider about if the fuel cell as a first priority, don't you worry about to lose your market share? You don't worry about that. In the future, we have a more electric vehicle that is imported from China or even some company made in Thailand. And for fuel cell vehicle, for the fuel cell vehicle that Toyota present many years ago, this is not commercialized. So I just want to ask your idea. Yes.
Hi. Thank you very much. The severe questions. Toyota, I already mentioned that Toyota have an all-encompassing approach. It means every items technology we have. Battery EV also, hybrid also, PHEV also, FCEV also. But point is a customer. Sometimes government or something, some persons forced to EV or something. But exist customer, exist market is the point. Who buy the vehicle? Even if forced, we prepare battery vehicle, but customer don't buy. That's no meaning. So that timing and categorize is very important. So at this time, we are searching for the customer market. So which kind of market, what kind of vehicle is suitable for? That's the point, I think. So at this time, now current Thai passenger car user want to buy battery vehicle, but price is twice time. So that's a difficult to buy. So but if cost is reduced, that's time customer buy. So timing is very important. So we are not refused to going to the battery way, or we are developing, but select by customer. That is our thinking way. So we need to starting for the customer and our technology, how to meet the customer's expectation. That is our challenge. get my cup.
And how about the fuel cell vehicle? The fuel cell vehicle? Yes, because yes, you have already developed it many years ago, but it's still not commercialized. What is the main, the most difficult problem? Why the Mirai cannot sell in the market, and then yet you show that you try to propose the fuel cell vehicle, fuel cell ecosystem for the big truck, something like that.
Yeah.
So is that is that when it will be possible in your idea?
The fuel cell vehicles, we developed the Mirai so many years ago. In this year, truly, honestly, many Mirai running on the Tokyo Olympics, but unfortunately, that's postponed. But at this time, Japan promote to the hydrogen. What is the issue? The hydrogen price and the infrastructure. That is the point. I already mentioned in my presentation, make a hydrogen is cheaper, but still emit the many CO2 is no meaning. So that the cleaner hydrogen, how to a cheaper price is a point. So, and also another infrastructure's point of view, infrastructure's cost is expensive. So that's very difficult to increase the station. That is the two issues of the hydrogen. Battery case is a station is currently cheaper, getting cheaper, so that many stations coming. But hydrogen case is very difficult. So at this time, Japan's issue is how to reduce the hydrogen price. And also, in case of the big truck and the bus, that case is, I think, no selection. Because if make a battery vehicle, short distance, okay, 100 kilometers or something. But long distance case, once charging 4 hours, 5 hours, something, that is operation efficiency is too bad. So that in case of the big truck and bus and the train and ship, like that's a big automobile transportation item, hydrogen is suitable. But point is fuel cost is still high.
Thank you. Yes.
As you know, for the country, Vietnam, Malaysia, or even our neighborhood countries, are attractive for investment. So many Asian industrialized countries, including Japan, have moved or have gone to invest in various businesses there. What I am eager to know is the policy, the future policy of Toyota about this issue. And in short, can you confirm that Toyota will be here with us as long as we can? Yes.
So sorry, I cannot catch. Again, please explain.
At this moment, many Asian industrialized countries move to new open Asian countries such as Vietnam or Indonesia to make business or industry. What I want to know is the policy of Toyota. This was the answer. If you can answer, it's good.
Okay.
If you cannot, it doesn't matter.
Okay. ASEAN country, we are responsible for the ASEAN country. So that at this time, Thailand have a core, industry core in the ASEAN. So many Japanese companies coming to the Thailand. But Indonesia also they have a same volume of the automotive area, so that we try to localize. The other, Vietnam or Malaysia is at this time little bit volume is small. But I think basically Asian country will require the localization, make an industry, so that production in each country is a basically basic idea, so that how to make a volume and then go to each country. At this time, almost country we have such a kind of plan. So we are going to start increasing, promoting such a business. It's okay.
Thank you very much.
Oh.
Thank you very much, Anipat Radisian from Chulalongkorn University. I have seen one of your slides regarding the cost of one of the slides regarding the cost of battery compared between the hybrid and BEV, and also together with the cost of, I guess, this one. Yes, from the first two in the top and also in the lower. Do you think is there anything to improve in the future if we move to BEV, not going to the fuel cell? Is that possible?
And this side is not changing, I think, because that depends on the electrified driving range. So that the hybrid one battery is 15 times can drive the EV more. So that this area is not changed. But how to reduce the battery cost is a point, I think. But US dollar 100 is a possible range, but sometimes some research companies say that reduce continuously like that. But at this time, almost 70 or 80% is material cost. So very, like this level is possible, but very, very difficult to reduce.
So that means at the cooperative is at the US $100.
Yeah. So that our idea is in case of the battery EV, short range and smaller vehicle is suitable for battery EV. It's mean weight is small, is battery cost is small. Distance is small, is battery cost is small. So that if select the battery EV, that case is such a kind of vehicle is suitable. That's our idea.
So it is a conclusion that we should not put as a definition that we will be replaced all the transportation, right?
That is a.
We cannot make a conclusion like that. We will be replaced all the IC.
My personal opinion is what is the purpose for like this electrification? That is reduce the CO2. If reduce CO2, it's technology itself is doesn't matter. So that
we need another class for the automotive. Is that correct? Not only this on your but we need another graph for environmental cost.
Yeah. So that biofuel is one of renewable. If like in case of Thailand, make many ethanol. Ethanol make from molasses. Molasses is make us sugar. Sugar make a sugar production emit the CO2. Remaining molasses is a no CO2 emission. Make ethanol, small volume of the emit the CO2, but that is absorb the CO2. And then use that vehicle. It's almost zero CO2, like that. So electrified is effective to reduce the CO2, but such a renewable energy usage is also important, I think. That time, what kind of mobility is suitable? Well, sometimes hybrid E85 or E100 is suitable. Like that, we have a many selection.
That's all the questions. So, once again, ladies and gentlemen, a big round of applause for our presenters. And also, thank you very much all the participants for your great participation. Okay, now I think it's time for the second keynote speech by our keynote speaker, Asst.Prof.Dr.Wirachai Roynarin, Head of Research and Service Energy Center, Rajamangala University of Technology, Thanyaburi. The title of the presentation that we will be giving is Innovation of Low-Speed Wind Machine for Thailand and ASEAN Wind Resource. Okay. While waiting for Assistant Professor Dr. Wirachai to get himself ready, may I tell you briefly about our keynote speaker. Assistant Professor Dr. Wirachai Roynarin works at Department of Mechanical Engineering, Rajamangala University of Technology, Thanyaburi. He received his PhD in 2004 in Mechanical Engineering from Northern Victoria University, Newcastle, England. His field of interest includes renewable energy, wind, water, and wave energy. At present, he is the Director of Research Center of Renewable Energy Division at RMUTT, President of Thailand Renewable Energy for Community Associations, or TRECA, and Head of Research and Service Energy Center, Faculty of Engineering, RMUTT. He is also a consultant to several organizations. For example, he is the academic consultant of Tsme Icome International Environment Foundation in Princess Tsme Icome, academic consultant in research section in Ministry of Science and Technology from 2005 up until the present day, and also the academic consultant in renewable energy of the Federation of Thai Industries, Ministry of Industry from 2007 until the present day. I think now our keynote speaker is ready. So once again, please welcome Assistant Professor Dr. Wirachai Roynarin.
Thank you very much. Thank you very much, and good evening for the floor. And as I am the last session today for the keynote speaker, and thank you very much for inviting me for the academic of the sharing of my knowledge of the mechanical engineer, and hopefully that my sharing of my knowledge of the machine will encourage people here to do some more research, and hopefully that we enjoy with the future of technology in innovation of low wind speed wind machine for Thailand and ASEAN wind resources. What the problem for nowadays, as you can see that we have some problem about the world globing and also the CO2 emission. Today I'm coming here to present of my knowledge and experience for 20 years of my research of the wind machine. What going to have the problem and what to solve the problem by our knowledge. For this time, for Icome 2020, in 2020, we can see that the renewable energy situation in Thailand for renewable energy, we're going to implement about the wind energy for nearly about 3,000 megawatt in the future of the time. But what the problem is, Thailand and Southeast Asian country, we have only about the wind speed about 4 to 0.5 meter per second. That is very low wind speed compared to the other country in the high wind speed zone like in European or in the States. If we want to have a very good quality of the wind machine, we have to design appropriated the wind turbine blade that is suitable for the wind velocity in Thailand and in Southeast Asia. As you can see nowadays, most of the wind machine designed for the average wind speed about 7 to 7.5 meter per second to achieve the power about 20%. Thailand have the wind average about 4.5 meter per second. If we bring the machine from abroad that designed for the high wind speed, they can generate only about the plant factor only about 8 to 10%. But if we want to design the wind machine appropriate for the wind velocity in Thailand, we have to design the average wind speed only about 4.5 to 5 meter per second. That we're going to approximate about 20% of the capacity of the wind machine. But most of the wind machine that I said before, they design about 7 to 7.5 meter per second for the wind velocity. If we bring the wind machine from abroad that not appropriate for the wind velocity in Thailand, that we can achieve only about 10% of the plant factor. That's why you can see most of the big wind machine megawatt site, they have to find the place that have approximate wind speed about 7 to 7.5 meter per second. Can see for the high like a Phetchabun province or some places in Thailand that we call Sopakor for the land. But if we want to use for the normal like near the coast, you can see the average wind speed in Thailand only about 5 to 5 meter per second. They cannot use the wind machine for around in Thailand because the wind speed compared to the design is very low performance. Okay? The point is in Thailand, if we can see the wind velocity, we potential wind speed about 4 to 6 meter per second, approximate about 1,600 megawatt. This 1,600 megawatt had to be the low wind speed wind machine design only. If we want to bring the wind machine like a megawatt size from Westat, from around the world or some places, we have to find the wind speed, the place that have to be approached about 7 meter per second. If you bring the wind machine from abroad, you have to find the place that's suitable, good design for the high wind speed wind machine. But if we want to use the wind machine for the low wind speed, about 4 to 5 meters per second, you have to design your own blade and own system. That's why, for the point of view, as you can see, the average wind speed in Thailand, the power density is not much like in European country or in the state. The power density, as I say to you that most of the wind machine designed to produce 20% of the rated power, you have to find the place 7 meters per second. But in ASEAN and in Thailand, we have to decide the wind speed only 5 meters per second to produce 20% of the rated power. That is the challenging of our engineer. That is for 25 years of my life to design the blade that's suitable for the low wind speed. By using the technique, even in European, they have some places, even in the ASEAN, they have some places that only average wind speed only about 5 meters per second. 70% of the world, we have to use the low wind speed wind machine only. What the problem is, if we want to do the wind machine developed for Thailand and Southeast Asia, we have to design appropriate blade for the high lift force at low Reynolds number. That's it. Our engineer have to know that how to find the blade's airfoil section to suitable for the low speed and low velocity. This is very challenge with the local line making. Wind machine, horizontal or vertical wind machine, they design for the lift force, lift and drag force. That is the affected to the power of the wind machine. The blade is the heart of the design. We are engineer, we are mechanical engineer, we know the fluid dynamic, we are knowing about the manufacturing, we know all the things. But how to find the suitable airfoil section that's suitable for the low wind speed area. That is the point of view. I've been in England for 5 years to research the suitable airfoil section and manufacturing, and now we export the wind machine to European countries, some places. We export the wind machine to the South Korea, to Japan, to produce very good quality of electricity for low wind speed zone. And we know that the blade is the heart of the wind machine. If we can find the suitable airfoil section of the blade, we can show all nearly 100% of the performance of the wind machine. The blade characteristic and the blade power curve is the main heart of the design. Like a vehicle, we have to design suitable engine, suitable for application. The wind machine also, we have to design the section area of the blade suitable for the local, for the speed of the wind at local, like a tailor-made. This is the section of the airfoil. We generate the lift and drag force. If the lift higher than the drag, most bigger lift, bigger good. The bigger is mean high lift, low drag. That means the generate very powerful torque to mechanical power and then electricity. This is the wind machine that suitable status for Thailand. We have 12 steps to design the wind machine from beginning, theoretical, and then prototyping, manufacturing, and then producing to commercial one. This is 12 steps that the engineer, our people have to do 12 steps of the design of the wind machine. That going to simple, even in Japan, in some places, not very high wind. But if you have very good wind machine design suitable for the local wind speed, at low wind speed, then you can do 12 steps of the design like this. This is the typical power curve of the worldwide wind market. You can see that If you bring the wind machine from abroad, or they design for high wind speed, you see the cut-in wind speed nearly 4 meters per second. Cut-in, that means just only start, not producing electricity or power, torque, anything, just cut in, okay? But cut-in wind speed 4 meters per second is the average wind speed already in Thailand. That means just cut in and stop, cut in and stop. They not produce any useful power or electricity suitable any. If we want to design the wind machine for Thailand, we need to design the cut-in speed only about 2.5 meter per second, and then rated not more than 9 meter per second. Compared to the high wind speed wind machine, they cut in 3.5 to 4 meter per second, and the rated about 13 to 14 meter per second. The general idea is how to find suitable the airfoil section that suitable for low wind speed. You know, before about 15 years ago, the vertical axis wind machine, they never self-start itself. The vertical one, they never self-start until I found out something. The wind machine for vertical wind machine nowadays, they can self-start by my airfoil section, R1235. I will show you later on. But this is the typical power curve. I want to show you that. If you can see from this is the typical high-speed wind machine or wind turbine. They generate 1,000 watt at rated about 11 meter per second and cut in about 3.5. But for our wind machine nowadays that we export to Southeast Asia, we rated only about 7 meter per second and cut in only 2.5. Then they generate the power triple time than high wind speed wind machine. As you can see, if you see from this is the power curve of the typical in the commercial design for high wind speed wind machine in States and European, that they have very high wind speed, average about 7 meter per second. They generate about 20% of rated power, 1,000 watt. They generate 7 meter per second at about 200 watt. But our wind machine at 4 meter per second, we generate 20%, the same. That means if you bring the machine from abroad to use at 4 meter per second, average wind speed in Thailand, you can generate only 8% of the rated power. Okay? How to do? Of course, the air wing or airfoil section like this is the main heart of the design of the wind machine. If we find the suitable airfoil section to generate very high lift force, not stall condition, very high lift force at very low angle of attack of the wind blade, then we can find out and solve the problem. But not easily like we think. CFD, computational fluid dynamics, we can find some problem. We can find out by using CFD to find the suitable airfoil section. Okay? Or we can use the program. We writing the program for the lift and drag. We call analytical model or mathematical model. This is, for example, this is my PhD. In my doctorate degree when I was in England, we use clockwise, for example, for airfoil section from NASA. We can generate very high CP power coefficient at tip speed about 7 meter per 7 times of the rated of the wind. We can produce about 0.4 or 40% to transform power from the wind kinetic moving fluid to the mechanical power. But they are not enough, not good enough. If we want to find a good one, we need about 10. But at 10, tip speed ratio about 10, they get lower power coefficient. That is not suitable. Clockwise not suitable for low wind speed zone. This is for example. But compared to the chord ratio, if we learn about the aerodynamic airwing section, we know that the tip speed about 10, the power coefficient very low for the normal airfoil section. Then it's not suitable. At the chord ratio about this, chord ratio is mean the solidity, how to make it flexible, not rigidity. If something is very rigidity, they have broken easily. Okay. Then we have to find out some parameter, some airfoil section. This is about 40 airfoil section. In different airfoil section, there are different lift and drag coefficient. Okay, but we have to find out at 40 airfoil section which one is suitable for the low wind speed wind machine. Which one? We do the analytical model, CFD, or typical making the airfoil section and testing in the wind tunnel to find out. Of course, this is the answer. And nowadays, the airfoil section named R1235, blade airfoil section is my surname, Roynarin. We have very high lift force at low Reynolds number. And you can see this is theoretical blade airfoil turbine. Compared to R1235 blade, we are spinning the blade, spinning faster than the normal one. You can see the CP, it means power coefficient. They can constant the power coefficient until nearly 10. If normal one at 10, tip speed ratio 10, the power coefficient very little. That cannot apply for high speed. The rotation, very high speed, cannot use at low wind speed. You can use high wind speed, okay? But if we want to use in Thailand, we need high tip speed ratio airfoil section. That is suitable for long range of long CP. From beginning from 3 meters per second to 5 to 10 meters per second, we can continue generate very high power coefficient. Okay? Then we find out Roy blade R1235. We generate very high power at low wind speed. From 45 airfoil section, combine, use advantage and disadvantage of each section airfoil, and then producing the blade suitable for low wind speed. And 70% of the area in around the world, we need the airfoil section of like thing like this. Now, we manufacturing the airfoil section and making the quality of the low wind speed wind machine to generate electricity to Toyota and to the world of the renewable energy. This is a airfoil simulation. The lift force CL over CD of the R1235 wind the 45 airfoil section. We have very high lift force at low Reynolds number and very small drag force at high Reynolds number. This is the point. But the secret is this is the blade making of 50 kilowatt. The first prototype making for the EGET 50 kilowatt wind machine that is rated only 9 meters per second going to rated power. This is the blade nowadays 400 kilowatt making in Thailand, Cobra, Thailand. Now we making the low wind speed wind blade and export to the world market of low wind speed. And now 100 kilowatt R1235 blade for low wind speed wind machine. Did it for 15 years since I graduated doctor degree. 15 years after find out something and continue research, and now we are going to be commercial. And we sell about 500 units of the wind machine by Future Technology Thailand, FT Energy, and by mechanical engineering by me. Like this, we test the quality of the blade. We have to know the pressure. We have to know the strength of the blade. We call 1 million times of rotation. That means we guarantee our blade 15 years of working, no maintenance. By testing, fatigue, and bending, maximum bending, high pressure and low pressure. Like this, bending test, testing the blade, strong enough for the typhoon, strong enough for the high torque, and continue like this. Simulation for them up to 1 million rotation. That means about 15 years of working time of the wind machine. This is the very art of work of the 100 kilowatt. As we can see, this is the 100 kilowatt wind machine. Generator, PMG, permanent generator, outside the nacelle, because we are hot and humid. No generator inside the house, outside. Your mechanism, everything, engineer, mechanical engineer. We are the one that producing the machine. All the design is patented by FT Energy, Future Technology Thailand, and we now making the 100 kilowatt. Maintenance, people can after CG, everything, FT Energy, Future Technology Thailand. And the new idea of hybrid, big megawatt site to the small site, that they are generate more power and optimized area of the wind farm. Because the small one of our 100 kilowatt can generate power at low wind speed. Then they're producing electricity at low wind speed. High wind speed, the megawatt site, the top about 100 meters from the ground level, combination of the area. Of course, the effect of the tower can increase the wind speed because I'm going to produce some word, Roy ratio, between small one and the biggest one. The tower is turbulent. You know the turbulent one, if the wind pass through the thing that turbulent, they can increase the speed. And the small one capture the increasing wind speed behind the tower of the megawatt size one. This is general idea. And we're going to do the micro siting of the wind farm. Combination between low wind speed and high wind speed wind machine to producing more electricity and optimizing area. This is the micro siting design. Megawatt site in the blue one and small wind machine to the red one. We can optimization of the world wind farm. They produce more electricity and they generate very good useful torque and electricity supply to the grid. By control, you can see that small wind machine using for the control and starting megawatt size machine. This is some application that 15 years of my life. The first one, I get the budget from the King Rama IX for the first wind machine, low wind speed at ไร่ช่างหัวมัน จังหวัดเพชรบุรี province. This is the first low wind speed wind machine in the world that is supported by our King Rama IX. If people go to the ไร่ช่างหัวมัน you can see this, the symbolic of ไร่ช่างหัวมันis the cow very happy life producing very good milk for us. Okay, That's why the signature of Rajamangala. That's it, my wind turbine, the first installation and commercial one. We are mechanical engineer. We are engineer. We do for our king. We do for our world. Okay? And this is the second project. This is the first project. Rajamangala. If we go to Rajamangala, you will see my faith and my symbolic over there. They are producing very good electricity for only a bit of the wind, only 4 meters per second average. In Thanyaburi province, this is some of the application. Hybrid system, wind and solar to generate power to producing hydrogen for you, for your electricity, for mobile charging and charging station in the future. Everywhere in the local, in the world, need low wind speed and solar hybrid system charging station. This is some in Chayapum province. That is our 10 kilowatt and 5 kilowatt floating wind. This is now we are commercial. I'm not the sale, but I'm the one is founder of Future Technology Thailand, FT Energy. I'm a professor. I producing a good thing for the world. This is, you can see that the rated power only 9.5 meters per second for 5 kilowatt, 10 kilowatt, 100 kilowatt, the same principle design. This is the hybrid system of Chayapum province for water treatment process, hybrid wind and solar floating. This is in Royet with Patato PTT, and we're going to produce now my student, my PhD student for floating wind machine. Nowadays, we're going to produce. This is the real one, the but small size. We make for PTT nowadays for low speed wind machine. And this is 100 kilowatt wind machine in Sriracha nowadays for testing for nearly 2 years. This is some you don't know. That is me about 10 years ago, very fat, but nowadays very thin because lose power a lot for the wind machine. This is the Monlan project for the Queen Sirikit project. This is nearly 10 years ago. 3 hybrid systems that I do. Okay, wind, solar, diesel, bidirectional inverter, and energy storage for our military project. This is nearly 10 years already. This Rajamangala project for 10 kilowatt wind machine compound together for 1 megawatt, 84 units together, producing good electricity to the Greenport project, Rajamangala Greenport. This is a monitoring system, and also you can go there and you can see the wind farm, and then you can see the vehicle transportation inside the farm. This is 1 megawatt. From King Ramanai project, 5 kilowatt each, and now we develop to 10 kilowatt each and 100 kilowatt for the wind machine. Inside the wind machine, you can see Roy blade R1235, high lift force, low Reynolds number. Okay, you can see PMGS, permanent magnet generator, synchronous generator, PMG, and we have the brake, e-brake. Okay, when the power, and we have the slip ring and yaw. This is some product, FT 100 kilowatt wind machine. We have produced a good one of the wind machine for low wind speed zone. It's special airfoil design. R1235 is my surname, Roynarin. And hopefully in the future, some of us or some of our professors can find one R1234. That means episode better than me. Okay, that's it. I leave number 4 for our student, our engineer, or who can beat the high lift force at low wind speed wind machine. Thank you very much.
Are there any questions from the floor? No questions? Okay. Thank you very much. Our second keynote speaker, Associate Professor Dr.Wirachai Roynarin, for his wonderful talk about wind turbine. And I saw wonderful pictures at the Thanyaburi project. I'll just give last month, and I was very impressed with the project. You did very good thing for the country. Thank you very much on behalf of Thai people. So, on this occasion, I'd like to invite once again the President of Thai Society of Mechanical Engineers to present the token of appreciation to our speaker. Thank you, our keynote speaker and the President of the Thai Society of Mechanical Engineers. Okay. All right. We have completed all sessions for today already. So, however, there is another session, interesting session for tonight, which is the city tour. What are we doing for the city tour?
For this conference, we're going to take you to visit very important temples in Ubon Ratchathani. Have you ever heard that the city is one of the city that has the most